Okay, so let's start. So, good morning, everybody. So, last time I explained, in the very beginning, I explained Aloha, right? And I told you in Aloha, the vulnerable time was 2TF. TF is the frame time. And frame time, TF is actually the frame size divided by the bit rate or bandwidth, if it is bit per second, okay? This is a vulnerable time. And also last time I explained the shorter this time is gonna be the better for collision. Is that okay? So you should understand, if you have less number of collision, that means we're gonna have higher throughput. It means the utilization of the channel is higher, because actually we are losing the channel. The utilization is low because of collision. You get what I'm saying? You should understand, as we reduce collision, the utilization of the channel is better, or the throughput of the channel of the medium is better, okay? And then last time also we improved Aloha, and we had what we call slotted Aloha. So it's another version of Aloha. We call it slotted Aloha. In slotted Aloha, the vulnerable period was only TF. Is that okay? That's why this one is better. Slotted Aloha is better, okay? And all what we did last time in slotted Aloha, it was just a minor change comparing to Aloha, okay? In Aloha, if you want to transmit, go ahead and to transmit immediately, okay? But in slotted Aloha, if you remember that's what we said last time, we have time slots, okay? So if I am here and I want to transmit, okay, you can't transmit. You have to wait until the time comes. Only transmission can happen in certain times. That's why we were able to reduce the vulnerable period time to TF, okay? Vulnerable, why we call it vulnerable time? Why use this name? Because this is the time, if there is no other transmission during this time, I will be very happy. That means there is no collision. You know what I'm saying? That's what we call vulnerable time. Because if there is any transmission during this time, there will be collision, okay? So, and for sure you should understand, any improvement we do is not for free. We have to pay the cost for that. The cost for that, number one, there is a delay, because if you want to transmit, if I want to transmit here, I have to wait. There is a delay, right? So this is the first thing. The second thing, all computers have to be synchronized. All of us should have the same time. We should be synchronized, okay? And then after that, last time I started to explain CSMA, okay? And I told you the idea is very simple in CSMA, okay? The improvement I did in CSMA comparing to Aloha is, CSMA is, before you talk, you have to listen first. You have to see if someone is talking or not. What do you mean? I mean, in CSMA, before you transmit, you have to sense the channel. If there is an ongoing transmission in the channel, don't make disruption, don't disrupt it, don't send. You got what I'm saying? That is why. So here you need to sense the channel before you transmit. If the channel is idle, you can transmit. Otherwise, you can't transmit. Okay. Again, nothing is for free. Yes, we can reduce the collision because you sense the channel before you transmit. However, yes, you can improve the collision. However, there is a cost. The cost is you need a hardware circuit for sensing the channel. Is that okay? And because of that, we were able to make the vulnerable period to 2 TP. Is that okay? 2 TP. Again, can I control TP? The answer is yes, because TP is actually the distance of the cable's distance, or the distance between two computers. or the cable length, length of the cable, okay, divided by the velocity of the signal, okay? That means the bigger is the cable is gonna be, you have more TB is bigger. Is that okay? A very important thing, and I'm quite sure I will ask this question in exams and quizzes and somewhere. I'm gonna ask this question, okay? Look, I'm very easy. I'm telling you what will be in the exam, okay? I'm telling you, but just you need to study. So what I'm saying here, it's very attractive for anybody teaching this course to ask a question like this, okay? So is CCMA is always better than ALUHA? The answer is no. It depends on, it's going to be better if the vulnerable period of time is less. Can you close this door? So because this is the vulnerable period, it's 2TP. So for example, if we talk about ALUHA, it is 2TF. Okay. So in order for, close the door after you enter, please. In order for CCMA to be better than ALUHA, there is a requirement here. 2TP has to be less than 2TF to be better than ALUHA. To be better than slotted ALUHA has to be less than TF. The vulnerable period has to be less. You understand what I'm saying? So maybe I'm gonna give, you should understand how can you calculate TF using this formula. You should understand how can you calculate TB using this formula. Maybe I'm gonna give you all the data needed to calculate TF and to calculate TP, and then I ask you in the question which scheme I should use. Okay, should I use ALUHA or should I use CCMA or slotted ALUHA? Which one I should use? Okay, for example. So here you need to do the calculation if the vulnerable period here, or there is the requirement here, 2TP has to be less than TF. Okay, so TTP, or maybe I'm going to give you like a design question, because this one can control the length of the cable. If you have a cable, the length of the cable. This one can control the frame size. Okay, for example, I give you everything except the frame size, and then I'm going to ask you what is the frame size, or what is the minimum frame size in order to make sure CCMA is better than ALUHA. You understand what I'm saying? So again, it's the same thing here, but maybe I'm going to give you some missing, something is missing here. Either the distance of the cable or the frame size. Okay, any questions? Okay. Also, last time I explained for CCMA, I explained we have three approaches for CCMA. The first one, we call it persistent CCMA. You can tell from the English name, persistent, insistent. You insist on something, you persist on something. You got what I'm saying? So this approach is very greedy. You will understand what is greedy, why it is greedy here. So if you look how it works here, number one, I'm gonna send a channel. Okay, if it's busy, send again, busy, send again, busy, send again. I'm gonna keep sensing until I find it's idle. Once it is idle, I'm gonna transmit. Okay. So what is the good thing about this one, and what is the bad thing? The good thing is once the channel is idle, I'm gonna transmit. I'm not gonna waste the time. So there is no, I'm not gonna waste time. Once the channel is idle, I'm gonna transmit. This is a good thing. You know what I'm saying? So I will try to use the channel all the time. Okay. What is the bad thing here? The bad thing is, as I said last time, there will the repeated collision. If there are two computers that are sensing at the same time, two computers want to transmit at the same time, sensing, the two computers are going to find the channel idle at the same time, and both of them are going to transmit here at the same time. Is that okay? This is the thing about this one. We are going to try to solve this problem here. The second one is called non-persistent. You are not persistent. This is the least greedy. You're not greedy. Okay. So the idea here is that I'm gonna, since the medium, if it is idle, I'm gonna send. If it is not, so I'm gonna wait for a random number. We call it back of period. So as you see here, I'm gonna send the channel. Is that busy? I'm gonna wait a random time, as you see here. Okay. And then is that still busy? I'm gonna wait a random. Once it's idle, I'm gonna transfer. Okay, so what is the logic here? The logic again is I want to solve this problem, the problem we had here. If two computers are competing for the channel, two computers are competing for the channel. Is that okay? So what happens here, hopefully, because I'm using here a random number here, a random number, hopefully, one computer is going to select a time here and another computer is going to select a time here. Is that okay? So that here it's 100% because once it is idle, you are going to just transmit 100% collision is going to happen here. But hopefully here, because of the random number you have here, two computers are going to select two different times. Okay, and we can avoid collision here. This is a good thing about it. I can avoid repeated collision. But what is bad about here? What is bad here is waiting time. So here you are the channel. It doesn't guarantee I'm gonna waste some time here because it's a channel is idle. Okay, but I'm not using it because I'm gonna wait for some time. You are gonna waste some time. Okay. So this is the bad thing. We don't have this problem here because once it's idle, you're going to transmit, but we have another problem. Okay. So what we did after that, I combined these two ideas together and I had what we call P persistent. P is the probability P. So as you will see right now, for example, it can be 0.5 persistent. So P, and when I implement this idea, you can put some number here instead of P. I can say 0.5. I can say 0.2. I can say 0.7, whatever the probability you have here. So the idea here, as you see, I'm gonna continuously sense a channel, similar to the first idea. So the first idea will do. Okay. But once I find the channel is idle, in the first one, I'm gonna transmit. Here, no. Once it is idle, so I'm gonna transmit with probability B. With probability B. What I'm saying? The other one, the first one, I'm gonna transmit with probability 1, which is 100%. All the time I'm gonna transmit. But this one, probability B. What do you mean by probability B? For example, if P is 0.5, so 50% of the time I'm gonna transmit, 50% of the time I'm not gonna transmit. Okay. And then I'm gonna wait one time slot, and again I'm gonna transmit with probability B. With probability B. Until it hits or until then I transmit it. Okay. So the idea here is that number one, hopefully, because we have two computers, okay, here the two computers are gonna find the channel at the same time. Two computers are gonna find its ID at the same time. But because we transmit with a probability, maybe this computer is gonna say, I'm gonna transmit this one. No, I'm not gonna transmit because of that probability. You know what I'm saying? For sure, it may happen that both of them will decide to transmit at the same time. Yes, it can happen, right? And in this case, we can have collision. I didn't claim we can just reduce the collision, but we cannot eliminate it. It can happen for sure. Okay. The higher the probability, the higher something like that it can happen. Okay? If it is 1, if the probability is 1, that means 100% is going to happen. Okay, but higher the probability is going to be higher. Okay. Anyway, so now today this is the main idea of CSMA. Okay, today I'm gonna explain two enhancement to this idea. Two enhancement. The first enhancement, we call it CSMA with CD. CD here means collision detection. The second one with collision avoidance. Okay, so now we have the original. We have the CSMA. We're going to have enhancement. We call it CSMA with collision detection. We have CSMA with collision avoidance. Enhancement to the CSMA. Okay, so I'm going to explain them. But before I explain them, let's take the attendance. One 133. 133. Make sure you take the attendance now, because if you wait, if you come me after the lecture and you tell me you didn't take the attendance, I'm not gonna allow you to take it, okay? So make sure you take the attendance now. And don't share the code with anybody because I'm gonna count. Okay, are you done? Okay. Okay. We have 18 students. I counted. Okay. Done? It's 20 students. I'm gonna waste the time and call names, but this time I'm gonna report what happens to the department. If that's not correct. Fatima, Ahmed Izzat. Fatima, Ahmed Izzada. Sarah Al-Ghani. الدوسري هلا ولا هيلا الدوسري؟ فاطمة وفاطمة الكعبي. ريم الكويري. الشيماء المسلح. مها النعيمي. جواهر الهي. أسماء النعيمي. بتون. بشاير الكويري. سارة المنصوري. الماري أسماء. عيشة ليلى. معلش يعني انا بعرف عربي الحمد لله كويس جدا، بس في الانجليش ساعات لما بين الحروف بالانجليش من انجليش لعربي الدنيا بتبوظ. شاذة الشيخ. شاذة ريم لاكان. عبير. مديار. عفيفة. يمنى نصر. سلمى صقر. Okay, so let's start with the first enhancement. So the first enhancement, as I told you, it's called collision detection. Okay, so what this one is gonna do in okay, number one, you should understand what we are gonna do here is not, or this enhancement is not gonna reduce the collision probability. So if you have 100 collision, still you are gonna have 100 collision. So I'm not gonna reduce the collision probability. But this one here, or this enhancement aims to, we wanna recover quickly from collision. I want to reduce the damage. Collision happens, okay, and then we want to recover quickly. So what we did before is that you transmit the whole frame. If someone also there is a collision, you have to transmit the whole frame, And then if I don't receive acknowledgement after a certain time, I know there is a collision. That's what we did before, right? But now, what is in this enhancement, why I wanna recover quickly. Why I waste all this time? Okay, I have to transmit the whole frame, wait for acknowledgement until I know if there is a collision. So, okay, can I do something better? Yes, I can. What I'm gonna do is, when I transmit, I'm gonna sense at the same time. So I'm gonna do two things at the same time: transmission and sensing. Okay. Once I find there is a collision, I'm gonna abort. I'm gonna stop transmission, and then I'm gonna send a jam signal to everybody. I'm gonna say, guys, there is collision. Stop transmission. I want to recover quickly. You understand the idea? So instead of waiting until you transmit the whole frame and then you wait for acknowledgement until you know there is collision, you are going to waste too much time. I want to recover quickly. When you recover quickly, you can improve the utilization of the channel, because our enemy is the waste time. If you waste time, because you remember, in order to achieve 100% utilization, I want to just transmit. All the time you transmit, don't make the channel idle. Okay, so again, the main idea here, this is, don't be confused, this is different from the sensing we did in the very beginning. Before you transmit, you have to sense. This is a different story, because it is CSMA. What is new now? In any CSMA, you have to sense before you transmit. But now, while you are transmitting, I'm gonna also sense two things at the same time. Once I find there is a collision, I'm gonna stop transmission. I'm gonna send a jam signal to everybody to tell everybody there is a collision. We need to stop quickly. Don't waste more time. Stop and let's try again. Okay, this is the main idea. So CSMA is not gonna reduce the chance of making collision. It's the same probability of making collision, but it aims to recover quickly from reduce the damage. Okay. So someone can ask me, how can you detect, how can you know if there is a collision or not? By sensing. I'm going to tell you how. Very simple. The idea is that if you transmit a certain signal, okay, and then when I sense the channel, I find the power of the channel is different from the signal I transmit. What it means? Okay, so now I transmit a signal. I'm going to sense the channel. If I find what I sense from the channel very close to what I'm transmitting, that means there is no collision. I'm the only one who transmits. You get what I'm saying? But if someone else is transmitting, I'm going to sense a different signal. The signal is going to be different, because the two signals are going to be added together. So the power of the signal is going to be different. That's how we can. For example, very simple example, if you have a cable, if I put here, for example, 5 volts, someone else can put 7 volt. If you measure the voltage here, we find the voltage is 14. Okay. 14, what? 12. Okay? 7 plus 5. Okay. So anyway, so that's how we can sense a channel. Okay. So here, what I'm seeing here, you send a jump signal to notify other nodes of collision, and then you have to abort the transmission here. I have several figures here to understand this idea. So if you see here, we assume here computer A is going to start the transmission at T1. I start the transmission here at T1, and because of the propagation delay, as you see here, this is a time. Remember, this is the time. Because of the propagation delay, this signal is going to arrive here, okay, at time T3. I'm going to call it T3. Okay, we have another computer called C. This computer C is going to start the transmission at T2. Okay, but keep in mind, look here. At T2, here at this moment, at T2, before computer C transmits the signal, computer C is going to first sense a channel. When it sends the channel, it will find the channel is idle, but the channel is not idle, by the way, as you see here. But because of the propagation delay, C didn't receive the signal yet. C didn't receive the signal yet. Okay, so at time T2, when computer C senses the channel, it will find the channel is idle. So that's why it's gonna make the decision to transmit. Is that okay? Because this signal is gonna arrive because of the propagation delay at time t3. Okay. So what happens here is that computer C is going to start at T2, but because while I'm transmitting, I'm also sensing. Because of that, I'm going to detect the collision here. I'm going to detect the collision here at this time. Is that okay? At T3. Once I detect the collision here at T3, I'm going to abort. I'm going to stop transmission. So this is the transmission period. I started at T2. I detected collision at T3 when this signal came to me here. So this is the transmission time here. I'm going to stop transmission. Same thing for computer A. So for computer A, you are going to start at T1, but the signal here is going to arrive to you at T4. At T4, I'm gonna know there is collision at T4 when this signal comes to me. Is that okay? And then I'm going to stop transmission T1 from T1 to T4. Any questions? This figure is exactly similar to the previous figure. So you see here, I start the transmission here. Okay, I start the transmission here, as you see here, and then I'm gonna abort here. I'm gonna stop here. So that's why we wasted, for sure, we wasted all this time. So we wasted the time from T1 until we recover, until T4, okay, or maybe after T4 until here. Okay, so wasted all this time, but at least it's better than continue transmitting the whole frame. We abort. Once we know, we stop transmission. Any questions? Okay, so this figure, this flow chart is exactly something like what I explained, but just summarize what I explained. So here, number one, this is CSMA. Okay, number one, you have to select one of the methods I explained for CSMA. I told you we have non-persistent, we have persistent, we have P persistent. Okay, by the way, the first one we call it persistent, or sometimes we call it one persistent. Okay, listen to me. So here, just I don't want to be confused. The first one here, persistent, and the last one, P persistent. It's persistent with a probability P. I told you, if the probability P is 1, this scheme will be similar to the first one. Because once it's idle, you are going to transmit 100% because it's 1, right? So that's why the first one, either we call it persistent, or sometimes we call it is persistent with probability 1. It's the same thing. Okay, sometimes you call it 1 persistent. Okay, 1 here means probability 1. Anyway, so as you see here, once I select what method I'm gonna use, when I come to here, I'm gonna check either I'm gonna see if the transmission is done or collision detection. So when I transmit, one of two things can happen: either I finish transmission or collision happens. Okay, if yes, if any one of these two happens, if yes, okay. If no, let's with no first. If no, so I didn't finish transmission, I didn't detect collision, so I'm gonna keep transmitting. As we see, I'm gonna keep transmitting, and then I'm gonna detect collision again. Keep transmitting, I'm gonna detect collision. Okay. So until one of two things should happen: either transmission is done or collision is detected. So I'm gonna come to here and see. I want to see the reason why you came to here. Did you come here because transmission is done or because collision is detected? So here, if it is yes, so collision. If you come to here, means that transmission is done. Okay, so I'm gonna come to here. If one of two things happen: transmission is done or collision detected. Collision detected, I'm gonna move this way. If transmission is done, I'm done. Right? I finished transmission. Okay. So now, if you detect the collision, what should you do? As I told you, number one, you have to send a jamming signal. So it's a signal with very high power to notify the other people. Guys, there is I detected collision. Stop transmission. Okay, so this is what we call jamming signal. It's a signal with very high power. Once it's something if everybody can know this jamming, because no one is gonna transmit with this power. Okay. And then you are going to wait for a random time. And then go back and repeat again. So the random time here is similar to what I explained before. If K is the number of failures, how many times you failed. Okay, so every time you fail, you increment K, and then you calculate the time. This is similar to what I explained before. Okay, you wait for random time and then repeat again. Any questions? Okay, so there is very important requirement here. Okay, the requirement here about the minimum frame size. Okay, what is the main point here? I'm going to tell you what is the main point. As I told you before, in order to take the collision, it's going to take two TP. So as I explained before, here, in order to detect the collision, it's going to take two TP, in 2 TP at most. You got what I'm saying? 2 TP. Okay, so here the main idea of collision detection is this is TFR, the frame time, okay, transmission time. The main idea is that if I detect, I wanna, instead of wasting too much time to transmit, and then after that, the collision. No, I want to detect the collision as early as possible, and then stop transmission to try to recover. Is that okay? So now I told you it's gonna take, if there is a collision, at least I need T2B to detect the collision. Is that okay? So what if the frame size is less than 2 TP? What it means? If the frame size, not frame size, if T part of this time, okay, if this time is less than 2 TP, T2P, what it means? It means I'm gonna stop the transmission and finish transmission. Collision happens, and I didn't know that collision happened. You understand what I'm saying? Because it's gonna take 2 TP in order to know if there is a collision or not. You understand what I'm saying? So this is it has to take this time. So that means in order to benefit from CD, so that's very useful now. Because also the idea is I need to detect the collision early and stop transmission in all this time, right? But if you already finished transmission, so CD is not going to be helping me. It's not going to be useful. You know what I'm saying? Because you already finished transmission. So that's why in order to achieve some gains from CD, I have to make sure that TFR, the frame size, should be greater than or equal to TB. Why? Very simple. Make it simple. I'm going to make it simple. I have to make sure before I finish transmission, I have to make sure if there is collision or not. And in order to be able to take the collision, you need 2 TP. Otherwise, you're going to finish transmission, collision happened, and you didn't detect it. You got what I'm saying? So anyway, so this requirement is very important. So there is a requirement on the minimum. Minimum should equal. At equal should be minimum. Okay. So that's what I'm explaining here. The minimum frame size. Here, what I'm saying here, you must detect the collision before finishing transmission. Otherwise, you are not gonna improve the utilization of the channel. Okay. I just added hardware, extra hardware to do sensing, but I didn't gain anything. Okay. So here, the transmission must continue at least 2 TP in order to be able to detect the collision. Okay. So this is the requirement here. TF has to be greater than 2 TP. Okay. Greater than or equal. But for sure, I'm not gonna work at equal. So you can say its minimum is gonna be at equal. Minimum is gonna be exactly minimum. Okay. Again, this is for sure very important. Maybe I'm gonna ask in exams and quizzes. I ask something related to this one. You need to. This is very attractive to me to ask. Also, you should know there is another requirement. I explained before. If you are using Aloha. If I'm using Aloha, I have to make sure 2 TF has to be greater than 2 TP. You remember vulnerable time. So in order to for CCMA to be better than Aloha, the vulnerable time has to be less than the vulnerable time of Aloha. So this is a different requirement. Okay. Remember, TFR has the frame size. TP has the cable length, the length of the cable. Okay. So maybe I'm gonna give you some numbers here. I'm gonna tell you what is the minimum frame size in order to make sure CCMA CD is better than CCMA without CD. Okay? So I have a numerical example here to help you to understand better what I'm saying. So here I'm telling you I have a network. I'm using CCMA CD. The bandwidth is 10 megabit per second. Okay? 10 megabit per second. Also here I'm telling you the propagation. This is the propagation time, TP. I give you TP, and this is the bandwidth, bandwidth or bit rate. Then I'm asking you about here what should be the minimum frame size. Minimum frame size. I told you about the condition that at least TFR has to be greater than or equal. So the minimum is going to be at equal, okay? But for sure it has to be more than that. So here I'm going to say TFR should equal to TTP. I give you TP here, you multiply it by 2. So this should be at least the transmission time of frames, 51.2 microsecond. Is that okay? And then giving the bit rate, you can calculate the frame size. Why? Because you know TFR is actually frame size divided by the bit rate or bandwidth. Okay. So yeah, this is the bandwidth here. So so you multiply the bandwidth by this time, I'm gonna get 512 bits. So this is the minimum. This is the minimum frame size in order to make sure CD is gonna better than CCMA, in order to make sure I can detect a collision before I finish transmission. So the whole idea is I need to detect the collision before you finish transmission to stop transmission, to save time. This is the whole idea, right? So I have to make sure the parameters, the design of the circuit, the design of the network is gonna help me to do this improvement. Okay. Otherwise, I'm gonna finish transmission even before I detect collision. Okay, it's gonna be useless. Any questions? Okay. Now I want to compare between Aloha and CCMA. So here, this curve, I already explained this curve before in Aloha. As you see in Aloha here, it is increasing and this is G. This is how much transmission we have, and this is S, the throughput or the utilization. As I told you before, Aloha, the maximum for Aloha is 0.118. 18% is the maximum you can get from Aloha. At this moment here, the utilization is going to be reduced. It's going to be less because of collision. So collision is going to reduce the transmission here. For slotted Aloha, it's exactly the same thing, but here it's going to be better, 0.36, as I told you before, and then after that it's gonna reduce because of the effect of collision until it is 0. 0 is terrible. So 0 means all the transmission we have are gonna make collision, all of them. So we are not using, the network is disabled. Okay, terrible for sure. Now let's see CCMA, how CCMA can be better. So CCMA here, one persistent. This is the one persistent. Okay, as I told you, this is persistent. So in persistent, you can see it is better than Aloha. You can go up here, but still the effect of collision is so bad. Okay, because as I told you, once you find the channel idle, we just transmit. So we're gonna create a lot of collision because of that. Now I'm gonna try CCMA with different persistence. So for example, 0.5 persistent, 0.01 persistent. Okay. For example, 0.1 persistent with different persistent. Okay. For sure, you can see here, at least in these cases, you can see the effect of collision is very, very small. Okay. I almost eliminated collision. For example, here, this one is very close to 1. You know what 1 means? 1. That means you fully utilize the channel. That means we don't have any collision, 0 collisions. You get what I'm saying? So here you can see here, for example, this one is doing very, very well. we almost have no collisions here. Okay. Any question? I have another curve here. This curve for the maximum throughput. So this is for throughput at different value of G, but this is for the maximum. You know the maximum here, the maximum. Okay. This is the maximum. Okay. And also here, x-axis is the relation between TP and GFR. TP divided by GFR. Okay. So there are several things we can see here. For ALOHA, the maximum is constant. So the maximum does not depend on TP, the ratio between TP and GFR. For slotted ALOHA, it is constant. Okay. It does not depend on the ratio between TP and GFR. It's constant. Okay. Also, we can see that's what I explained to you before. CSMA can be worse here in these areas, as you see here. This is CSMA. It can be worse than slotted ALOHA and ALOHA if it depends on the ratio here. And that's what I told you before. I told you in order for CSMA to be better than ALOHA, we have to make sure TTP, which is a vulnerable period for CSMA, I have to make sure this one less than TF in case of slotted ALOHA, 2TF in case of slotted ALOHA. If this is not true, so ALOHA and slotted ALOHA will be better. That's what we see here. Okay. Also, we can see here collision. CSMA with collision detection is better. We can achieve better utilization, okay, than the other ones because of the CD, the effect of the CD. Also, we can see when at a small value here, you know what it means when we have a small value. What it means? It means GFR is much bigger than TP. When GFR is much bigger than TP. Okay, here you can find, if you come here, you can find we almost achieve very, very high utilization. Especially here, you can see CD is doing much better here, okay? Because you are not gonna wait until you finish the transmission, right? You can approach the transmission quickly and try to recover quickly. Any questions? For sure, I'm not gonna ask you to memorize this curve or even this curve, but for sure, at least for ALOHA, you should know it's 18%. You need to memorize this number. Here, you need to memorize this number 0.36. Okay, but the purpose of this curve is just to understand what I explained. Okay, so you should for example, I explained. I told you before, CSMA can be worse here and here. So I just want to show you this. Also, I want to show you CD, CSMA with CD is actually better, and this makes sense, right? Because it can recover better than CSMA. Any questions? Okay, so now I'm gonna move to the next one, the next enhancement, which we call it CSMA CA. CA means collision avoidance. Okay, so first of all, let me tell you why we need this enhancement. I'm gonna tell you why. But first of all, I told you before, how can you know if there is, how can you detect a collision? I told you how can we do it? You are gonna measure the power. You are gonna measure the power on the cable, right? So if this is a cable, you are gonna measure the power on the cable. You are gonna compare it to the power of the signal you transmitted. If you are the only one that is using the cable, so the power of the signal you sense is going to be too close to the power you transmit. You got what I'm saying? If I'm the only one. But if someone else is transmitting, what I'm going to sense is going to be different from what I transmit. Okay? Okay. So that's how can we detect collision. However, in case we can't, it's going to be difficult to detect a collision in case of wireless communication. In case of wired communication, it's okay. But in case of wireless communication, it's going to be difficult to do collision detection. Why? I'm going to tell you why. Because in case of wireless communication, the signal you receive usually it's a very weak signal. Anyway, this is not the case in case of cable. So in wireless communication, the signal I receive is actually very weak signal. Okay. So when you transmit your own signal, and then you send a channel, because the one I'm receiving, it's a very small one. It's going to be too difficult to, it's going to be too hard to know if there is collision or not. Okay. Or if there is, because this, so my signal is going to overwhelm this signal. You got what I'm saying? That's why it's going to be difficult to detect collision, right? Because you add very small number to your transmission. So when you sense, you will find they are very close. You understand what I'm saying? So we need another approach. We need something different from CD, and that is why this was the motivation to do collision avoidance. Okay, so collision avoidance, it's an alternative. Collision avoidance is an alternative for collision detection. In case you can't do collision detection because of, especially in case of wireless, where the signal you are receiving is a very small signal. This idea is used in Wi-Fi. Do you know this protocol? This is a very famous protocol. We use it in our computer, IEEE 82.11. So in this protocol, this is what we use in Wi-Fi. Okay. This is a medium access. This is CSMA, by the way, CSMA protocol. We're gonna add collision avoidance. Any question? So what I want you to understand now is why we need collision avoidance here, because collision detection is not possible in case of wireless transmission. Okay, so we need another way. Okay, so the other way is, so what we do here, okay, in collision avoidance, I'm going to tell you what we do. What we do here is, before I transmit, I would try to do something like reservation to the channel. I want to do something like reservation to channel. How? I'm going to tell you, before I transmit my data, guys, I want to use the channel. Please don't use it. The channel is mine now. I'm going to send a signal to everybody. I'm going to tell everybody, I want to use the channel. Please don't use it. Okay? And then after that, I can guarantee no one will disrupt me. Okay, so it's like I visit the channel, okay, and then I can transmit. Okay, that's exactly what happens. So for example, here in this scenario here, as you see, A want to communicate to B. Before they start transmission, they have to do something like reservation to the channel. How? A is going to transmit a signal, we call it RTS. RTS stands for request to send. And who is going to hear this signal? The neighbor of A. So the neighbor of A are going to hear the signal. Okay. So I'm going to tell A is going to tell its neighbors, guys, don't transmit. I'm going to use the channel. The channel is mine. Okay. To make sure once I transmit, no one will disrupt me. No one will make collision. Okay. This is number one. Is that enough? Enough? No, it's not enough. What else we should do? The receiver B has to do the same thing to make sure no one from the neighbor of B is not going to make this disruption as well. As you see, so A want to talk to B, right? Simply because some nodes like this one, this node is neighbor for B, but it is not neighbor for A. So this one is not going to receive RTS. Right? So after B receives RTS, B is going to do the same thing here. It's going to send a signal. We call it CTS. Here to send. It's going to send to A. Using the signal, B is telling its neighbor, guys, I'm going to receive communication. Please don't transmit. Okay? Once I make sure the neighbors of A are not going to make disruption, and the neighbors of B are not going to make disruption, I can, by this way, 100% there is no collision. If no one in the neighbor, the area of A, okay, is not going to transmit. Same thing for B, because listen to me, collision can happen either at A or it can happen at B. You got what I'm saying? So maybe no one is not going to make disruption from neighbor of A. But when you transmit signal to B, someone else here, okay, like D, for example, is gonna make collision here at B. You got what I'm saying? So that's why, as you see here, number one, if number one, A has to send a signal, we call it RTS, okay? Number two, B is gonna send CTS. Once the neighbor of A, which is C, receives signal, so this one is gonna wait for a random time. It's gonna back off. Okay, so I'm not gonna transmit, I'm gonna wait, as you see here. Once you transmit CTS here, so the neighbor of B, which is D, also is gonna do the same thing, it's gonna wait. And now you can start the transmission, you receive acknowledgement, and now the channel is idle, anyone else can use it. Any questions? Let me ask you a very important question. Using this idea, can we eliminate collision at all? We can have zero collisions using this idea? Or still we have some collision? Why? If I tell my neighbor, don't make disruption, and you tell your neighbor, don't make disruption, there should be no collision. Is that right? Because no one is going to transmit from my neighbor, no one is going to transmit to your neighbor. You are right, but why? Why? Yes, still we have collision. So always in random access, always we have a collision, always, but we try to minimize it. The answer, yes, because maybe collision is going to happen to RTS itself. For example, you send here RTS, okay? When you send RTS, there is something with the hidden terminal. And hidden terminal, this code didn't receive the signal because it's outside the area. It didn't receive RTS. So maybe by accident, this one is going to transmit or send something and collide with RTS. You get what I'm saying? So yes, still we can have collision if RTS itself, if RTS and CTS collision happens to RTS or CTS. In this case, collision is going to happen. Okay, but the good news is this RTS and CTS are small signals. The size is small, and because the size of is small, the probability to have collision with them is very small because the transmission time, as you see here, the transmission time is small. Okay. Any questions? Okay, so you should understand here, yes, we still can have collision, but we try to minimize it because RTS and CTS are small. We're gonna have a quiz. The second quiz is gonna be on Thursday. Is that okay? It's gonna cover only chapter 5. It should be easy. I know some of you may not midterm on Thursday. على طول عندكم midterm طول السنة midtermات. هو في كم كل مادة كم midterm؟ لا هو هيبقى الخميس لأن الكويز اللي بعديه هيبقى قبل العيد إن شاء الله، يعني بفور الهوليداي بتاعت العيد خلاص هيبقى في كويز تاني هيكمل الشابتر ده. بقى هنخلص الكويز قبل العيد إن شاء الله. يعني يا شابتر 5 كله شابتر كل السلايدز بتاع شابتر 5. اوكي it should be very easy بتاع، بس انتوا بس ذاكروا شابتر 5 وان شاء الله يبقى ايزي. ماشي.